Unit 3. First topic is principle of sampling oscilloscope. Here the block diagram of the sampling oscilloscope is shown here. Here as usual input signal is given to vertical amplifier. Before that one more block is there, sampling gate. Here similar to conventional oscilloscope, here also we are having a triggering input oscilloscope, oscillator and then ramp generator, that it will be directly given to horizontal signal in conventional. But in sampling oscilloscope, here one more block is a converter voltage comparator, and then staircase generator is included with attenuator feedback. Okay, what is the basic concept behind the sampling oscilloscope? We know that what is called a sampling. The given input is like this one, it will be sampled like this one. This will be taken, this will be neglected, this will be taken. That is a sampling will be occur. The corresponding the ramp generator will be like this one. So whenever the input signal to the vertical input is sampled, correspondingly in a horizontal plate we have to put a piece of ramp. Okay, piece of ramp. So the ramp in the horizontal plate, it will become, instead of ramp generator, it will become a staircase generator. Okay, so that is a basic principle. Once again I am repeating, the input signal given to the vertical plate will be sampled properly by using a sampling pulses. At the same time the input to the horizontal plate will be sampled properly. Therefore the ramp generator in the horizontal plate become as a staircase generator. We can see how it is working. The bandwidth of the ordinary oscilloscope is 10 megahertz. The high frequency performance will be obtained by performing a sampling frequency. Sampling frequency is very important. The given input signal is sampled and it will be reconstructed from the sampling. First it will be, say, input signal is sampled and then reconstructing the input signal. Then the sampling point will be advanced for take another sample. Here the first point is sampling here, next point, and so on. Okay, like this. Okay, the sampling frequency is as low as 1/10 of the input signal. For example, input signal is 100 megahertz, the sampling ratio is as low as 10 megahertz. Therefore we can get near about 1000 samples are used to reconstruct the original waveform. The block diagram is shown here. Okay, we can start. The input signal is applied to the sampling gate. The sampling gate allows the input to the vertical amplifier whenever it gets sampling pulse. Then the input signal is delayed by a vertical amplifier, allowing the horizontal sweep to initiate by the input signal. First the input signal is given to sampling gate, and then here delay will be there, then vertical amplifier. Okay, similarly the horizontal plate, that will get a trigger input to the oscillator, and then the ramp will be generated, that will be given to the voltage comparator. Okay, then the input signal is delayed. Okay, the waveform of the sampling oscilloscope is shown here. At the beginning of the cycles, the trigger pulse is applied to the oscillator. Here the trigger pulse is given to the oscillator, and then the ramp generator, and then voltage comparator. Okay, thus the oscillator activates the ramp generator to generate the ramp. The ramp voltage is given to the voltage comparator. Then the voltage here, the ramp generator is given the input to the voltage comparator. Then voltage comparator generates two output. One is given to the sampling gate, another one is given to the staircase generator. Okay, the voltage comparator simultaneously generated two output, one to the sampling gate as a sampling pulse, another one is a staircase generator. The voltage comparator, what is a voltage comparator? Here that is a voltage comparator having a two input and then one output. The based upon the input, the output is switches from positive to negative or negative to positive, or whenever which one is a higher the output switches. Here the previous, that is having a feedback, the voltage comparator having a feedback from the previous output. Therefore the initially the first sample is here. This output will be given to the comparator as a feedback. Then the next ramp, it will compare. The trigger pulse is given at the ramp. Then the sampling pulse is, whenever that will be sampling pulse is generated by the comparator whenever the previous input from the gate from the horizontal plate is given to the comparator. Here the ramp will become, when both are equal, this point and this point, the sampling pulse will be generated. Sampling pulse, the gate is opened. Okay. The voltage comparator compares and the feedback from the staircase with the ramp voltage. Since the voltage compares receives the feedback from the staircase generator, previous output acts as one input to the comparator. Then another input from the ramp generator. Then the voltage comparator compares and generates the output as a sampling pulse, and staircase trigger pulse is to the staircase generator. Thus the ramp voltage equal to the staircase. The sample pulse and one step is incremented by the staircase generator is initiated by the voltage comparator. Therefore the input signal is sampled by sampling gate and it is applied to the vertical amplifier. Corresponding sweep voltage provided by the staircase generator. The resolution of the final image depends upon the size of the steps of the staircase generator. If the steps of the staircase is small, the large number of samples and the resolution of the image is very high.